Welcome to Study Loop.
So here we have the pressure that the pressure that we were given the pressure in the initial state and the pressure of the final state of this thermodynamic process, and we also have the starting temperature T1, and we are all asked to evaluate the final temperature T2. This is the temperature T2, and these are the parameters that we know from the beginning. So in order to do so, we need to find the direct relationship between these known values and this unknown value in order to evaluate the T2. So we know that the process is adiabatic, and we can start the deriving of the equation between these two parameters from the adiabatic state equation. This is the state equation that connects initial temperature T1 and the initial volume, so gamma minus 1, with the final temperature and the final volume. So from here we can say that the ratio T2 over T1 is equal to this ratio of volumes. Next step here will be to actually use the ideal gas equation in the next manner. So we know that P1 V1 is equal to nRT1. Notice how this term, n times r, does not change. P2 V2 also equals nRT2. So from this two, we can derive that P1 V1 over T1 will equal P2 V2 over T2. So this is the way we can relate this values. And why we do this? We do this to actually express this ratio of this and this, initial and final volume, with relationship to the pressure and temperature. So therefore we can say that V1 over V2 is equal to T1 over T2, P2 over P1. And this formula here will be substituted into the previous one. After substitution, we obtain that T2 over T1 is equal to, open brackets, T1 P2 T2 P1 gamma minus 1. Of course, we can expand this and say that is T1 over T2 on the exponent alone times P2 over P1 on the exponent alone. And this allows us to relate pressure ratio and the temperature ratio in a very neat manner. So this will be from here P2 over P1 on gamma minus 1, and then we turn this, we put this part on this side. So this will be immediately, we can say that it is T2 gamma minus 1 over T1 gamma minus 1 times T2 T1. This multiplication will get rid of this 1 in the exponent, and we obtain that P2 over P1, that is on gamma minus 1, actually is equal to T2 on gamma, T1 on gamma. And moving this gamma exponents to this side here, we can finally relate and say that T2 over T1 is equal to P2 over P1 gamma minus 1 over gamma. When we move exponents from one side of the equation to another side of the equation, they go from the numerator to the denominator, or vice versa. So this is how we obtain this part of the exponent. Further, we can say that, and now we can evaluate actually the T2. So T2 will be equal, notice this formula, T1 P2 P1 gamma minus 1 over gamma. This is the final formula. Substituting the known values, we obtain that this is 299 times 0.85 times 10 to the fifth, 1.101 times 10 to the fifth power 1.4 minus 1 over 1.4. This is kelvins. And finally, the result when we place these values into a calculator is that T2 equals 284.6 kelvins. This converted into Celsius degrees is 11.6 degrees Celsius. And this is the end of the problem. I hope you will find this helpful, and I hope to see you in the next lesson.